So this is kind of what we will look at today, how to bring your data into VR and AR and how to take advantage of the technology. So in the registration form, there's some simple survey asking about people's experience with AR, VR, and about half of the people don't have much experience with it. So because of that, I decided to do like an AR, VR intro, just a quick intro of AR, VR technology. But mostly we will focus on the resources that are available in KAUST via the KAUST Visualization Core Lab and go into more detail into the hardware, software, and skills that you need for AR, VR. We're going to take a break after that and maybe take some questions. And lastly, I want to do a lot of live demos, right? So I want you to try the headsets. And later on, we're going to, if there's time, we're going to move on to the other side of the building where we have the bigger facilities. So I want you to really try it and see for yourself and hopefully help you better imagine how you can use it for your research. Okay? So that's what we're going to do today. But first, I want to do a quick introduction of KAUST Visualization Core Lab. So it's one of the 12 core labs in KAUST. And the core labs, it's kind of an organization inside KAUST that provides expert support and collaboration to the research community. So we have different labs. We provide equipment, software, and collaboration, as I said. And I'm from the Visualization Core Lab, where we have 6 staff. And one of the things we provide is expertise in data visualization and data science, right? So we have someone who's working on information visualization, so more of your dashboards and web-based analytics. We have 3 people, including me, working on scientific visualization, more on, let's say, 3D data, simulations, flow data. And I myself, I help people with segmentation and also virtual reality and augmented reality. But we also have 2 data scientists who can help you take advantage of the supercomputer here in using it for machine learning, deep learning, and so on. Okay. So aside from the expertise, we also have facilities that you can book. So you can book these through our website. So we have the big display wall. You'll see this along the spine in Building 1, and we'll go there afterwards. We have that. We have the VR displays, the bigger ones, which we will take a look as well later on. And now the more popular headsets, because they're more portable, cheaper. So you can book these things, right? And use them for your research. And if you want to know more about the VisLab, this is our webpage. Right now, it's only accessible inside KAUST or inside the KAUST network. But if you're outside or if you just want to ask questions or discuss a project, you can send an email to our email address. So keep that in mind. All right, so now let's get into a quick introduction to AR/VR. So what is AR/VR? You've probably experienced some form of AR/VR, right? So if you've played Pokemon Go before, or if you use these video messaging apps where you can add stuff to your face or to your background, this is some form of AR, right? Because it's kind of blending the virtual with the real, right? And if you've played VR before, like this virtual driving simulator, I mean, there's VR and AR. Actually, they're mainly, or initially mainly developed for gaming, right? So if you've tried VR, most likely you've tried it because of gaming, right? And going back to what is AR/VR, a simplistic description is just a hardware and software system that lets you interact and display with a blend of real and virtual objects. Okay? Very simplistic definition. And it's common to talk about this reality-virtuality continuum, especially in the research world. So you have on the one end reality, which is where we live, the space where we are in. And on the other spectrum, you have virtual reality, where you're fully immersed, all around you is virtual. And then you have the in-betweens, augmented reality, where you bring virtual into the real world. And the less popular, but it's still there, augmented virtuality, where you bring real into the virtual. Okay? So today we'll focus on virtual reality and augmented reality. So I'll go right ahead and give a quick demo of a VR sample, just to give like right away a nice impression or idea about VR for those especially who haven't tried it yet. So this is a VR headset. It's a Quest Pro. And I'm just going to run a simple example. Okay. All right. So what you see here is what I'm seeing, right? And as I said, this is more for those of you who haven't seen or tried VR before. So you have the headset, and basically I have little screens right in front of my eyes. And what you see there is what I see on my left eye. So I have two screens, one for left and one for right. And this allows for stereoscopy, right? So I see kind of 3D because what's displayed on the left and right eye are correctly calibrated, right? Like how the eyes see objects, right? Slightly different. And I have a controller here, so that's my source of input, and you can see it there. So the head position and the hand or the controller position is tracked. So if I move my head, the camera position changes. Same with the controller, the position of the controller changes. And I have buttons here to interact with the game, right? And what you see here is a game. So I'll just show a few things. So I can click buttons to interact with the game. There's objects there that I can grab. So for example, this is already like an example where this is a 3D model of a coral that was extracted from a CT scan. Okay? So you can already see like some basic stuff that you can do with VR. And if you see the yellow thing on the ceiling, this is actually a 3D model of a coral. So let me go. It's this coral right here. So you can see it's hollow inside. And I just made it bigger and turned it into a dome. So I'm inside a coral right now, which is pretty cool, right? So you are inside your data. So imagine you can do something like this with your data as well. So this VR app is used right now in an exhibit in the library. So it's an exhibit that showcases the different data sets and collaborations between ANPERC. They have the CT scanner and different researchers in KAUST. Okay? There's more here, but I won't go through them all because of time. But later in the live demo, you can try it out yourself. Just wanted to show this like cool video of a rock and inside the rock. You can also have 360 videos, which I will show later. So this is VR, right? I think that's pretty cool. And let me just stop this. Yeah, so this was VR. And for those of you who haven't seen it before, hopefully you get a better idea. And later on, we will all try this out, right, as time permits. There's more examples. Okay. Yeah. So we have time. So this is another example of a VR application, right? So I would say it's one of the more popular ones. Google VR Earth, Google Earth. Yeah, so you can virtually tour places that are so far away, right, without leaving your room, which is pretty cool. And you have also like social apps where you can gather, socialize, have meetings, discuss, virtually. Of course, you can do this with Zoom and like all the other similar apps, but this one gives you like, the capability to walk around in 3D space, and maybe discuss some 3D assets. So you'll see some examples of that later. So it just has a different kind of presence. And now I'm going to show you an augmented reality example. So again, for those of you who haven't seen it yet, so in addition to those mobile applications, like the video conferencing or video messaging apps and Pokemon Go, you have headsets like this. So this is the HoloLens 2 from Microsoft, and it's an augmented reality device. So it's kind of similar to VR, right? The form factor. And I also have some sort of screen in front of me. So what you're seeing here is what I see. There's a bit of a delay, so don't get confused. It's not your brain. But for example, I have a menu. So it's like a mini computer, but the screen is everywhere, right? So I have the menu following my head position. And I can start an application by clicking using my finger. So you see, okay, I'm going to start an application. Okay. All right, so now I have some application running. Oh, okay, there's a delay. So this is a sample application that you can download online. Just showcases some of the interactions possible with the HoloLens. So for example, I have 3D objects here that I can grab, like 3D objects. It looks weird, right? I mean, from your perspective, I probably look so weird. But I was basically holding a cup of coffee. There's like this piano keys over here that I can actually press. And you don't hear it, but there's sound playing, right? So I have a virtual piano. You have these user interfaces. There's like a pen and whiteboard. I mean, hard to use. But there's stuff here, like I have this model of Earth. So it's great. I mean, can be useful for teaching, for instance, right? A lot of the advertisements for this is for teaching anatomy, for example, right? So you can have models like this that you can interact with. And I've put some data sets that I got myself. So that was a coral, 3D model of a coral. So it's right there. And I have some protein that we got from PDB. So it's something that you can play around with. And this is AR. Right, so I have the virtual, and some applications, you can actually interact with the geometry in the real world. So this device scans the surroundings. Let me just stop that. So the HoloLens scans the environment while you're using it, and it builds a rough 3D model of the world. So you can have applications that use that information. For example, your objects, you can place them on the table. So if you have gravity enabled, put things on the wall, on the floor, on the ceiling, these kinds of stuff. Yeah, I mean, you might be wondering right now, like, okay, what is this useful for, right? I mean, it's a bit tricky, but we'll get to that a little bit later, hopefully. So some other examples, so like Pokemon Go, you have this IKEA app that allows you to preview furniture in your space before purchasing. And you have, this is I think more a conceptual thing where you have people wearing HoloLenses discussing 3D assets. This I would say is also kind of a popular thing. It's a remote assist, right? Where you have someone who needs to use two hands, who needs the help of an expert who is remote, so you can do some setup like this. Okay. All right, so that was kind of a quick overview, or like just giving you an idea about AR, VR technology and some use cases, not yet for data visualization. Now we'll take a look at the different components of how it works, right? So first you have your input. So this is kind of like your mouse and keyboard, but instead you have controllers and cameras that track your hands. Then you have your computer. It could be, in this case, my laptop is doing the computations. For AR, there's a tiny computer in the headset. And you have your output device, which are the lenses that display something for you. So this is the hardware part of things. And of course, you have the software side. So you have an application, and you have your virtual content within the application, right? So you have hardware and software. In terms of hardware, there's, I would say, two big categories. One is the head-mounted displays, like the ones you've seen here. We also have these bigger environments, or caves, which we have across on the other side of the building, and we'll try to look at them later. In terms of software, we also have, let's say, the no programming required kind of application. So we have app stores where you can just buy software, right? Mostly games, but there's also some productivity and research apps. Today I will show you Aviso plus TechViz. So who of you here used Aviso before? Okay, interesting. So Aviso is a data visualization and analysis software that KAUST has a license of, so you can use it for free. And if you're already using that for your 3D visualization, with just a few clicks, you can bring your data in VR. Okay? And I'll show that later. There's other software that I won't talk about today. If you need more complex interactions, complex visualizations, you can build your application yourself, but this needs a bit of familiarity with the tools. The most popular ones are game engines, so that's what I was using earlier, which is Unity. So these are really software packages that help you build games. And we have plugins like Get Real 3D that allows your Unity game to be displayed on the bigger walls. Okay, I'll talk more about this later. So now we go to data visualization, right? So it's basically now you have your AR, VR application, but instead of just some random like 3D content, your virtual content is now your data, right? It's your 3D data that you now want to see from a different perspective. You want to interact with it in a different way. So basically take advantage of AR, VR to get something out of your data, right? That you cannot from your laptop or computer, okay? In the research world, this data visualization using AR, VR is sometimes termed immersive analytics. So there's a whole research field revolving around this. And the idea is, how do you leverage AR, VR to help research, right? So some of the ideas are for understanding 3D spatial data, like the coral reef, for example, analyzing situated data. This is data that has some physical world connection. You know, like maybe you have a machine that's collecting data in real time and you want to see it in its place. So I'll show some examples later. For performing natural interaction, right? So mouse and keyboard, we're all used to it, but it's not natural, right? If you're dealing with 3D things, this is still more natural, right? Like moving with your hands, moving your body. So there, VR and AR can have some advantages. Immersive storytelling. So this is another big field. So we have a bunch of examples of this that I will show later. So in the next few slides, I'll show some images and videos that give you some examples of these. And while I'm doing that, just try to imagine how your data can fit in the same situation, right? So the first one is for understanding 3D spatial data. So this example, we prototyped this from a data set given to us by Seymour, the Coastal Marine Research Lab. So this bathymetry data is basically the underwater landscape, kind of like how the ocean floor looks like. So of course you can look at this on the screen, but this can, I'm not saying guaranteed, but this can have a different benefit, right? So you can kind of imagine like swimming along the floor and seeing the structures, and you can scale it to actual size, right? So if you're a diver, this can have like, I don't know, additional benefit of getting a sense of the place even before you dive. So we can also bring it to the cave that I was talking about. So this is how it looks like. So here you can see I'm wearing the 3D glasses, and I have a controller that allows me to navigate the space. And this is great actually if you have multiple people exploring the data, right? Because the VR headset is just one person. I mean, people can see maybe on the screen, but this one is like collective experience. And we'll take a look at this later. All right. Yeah. So the next one is AR. So this is situated data. And what you see here, it was an application, or it's an application for teaching. So what the idea is, you have the HoloLens on, and you have some electric circuits in front of you, right? And the idea is that the HoloLens shows you the invisible things that are happening within the circuit, right? You can see some sound wave visualization, some current, voltage that you normally don't see, right? And it's there, you can see it in place, you know? This is the important part. It's in place, combined with the real world, yeah? Yeah. No, there's a attached sensor, and the sensor is connected to the PC, and then the PC is, yeah. No prediction here. But this is one of the challenges, right? I mean, how do you get real-time data? But it's usually just using sensors and transmitters. Yeah, the other one is this
IKEA would
IKEA
like
app.
everyone to know
I like
about
it because
Place,
it's
our
practical.
new augmented reality app. Built on Apple's new AR kit, you can easily place true to scale 3D models of IKEA furniture in your place. Scan, browse, select, move, and place.
Yeah, super simple, right? And you just need your phone. I would say this is a pretty cool and like sensible application, right? Aside from the games. So it's not just for furniture. I mean, you can use it for, I don't know, if you're building a lab and you want to visualize the space before buying equipment or planning and so on. This could be pretty cool. And you can also do that on the HoloLens. Natural interactions. So I'm not sure if you've played a game like this, but this one requires that, you know, you're pretty good with your hand and moving it in 3D space. But this kind of skill can be used for tracing neurons in 3D, right? So there was a paper a long time ago that did just that. And there's a video here that shows you. So doing this with a mouse and keyboard is difficult compared to doing it in VR. So this was, I think, one of the other practical applications of VR for research. So here you see in VR, they have a 3D visualization of the neuron data set. And then you just use a controller, right, to trace the lines. So it's like a game, simple game, but in the end, you get the connectivity map of the neuron. Yeah? Okay. So there was also a project in the Core Lab before where they did a VR tour of the brain cells. So you can try that out as well later on if you have time. But you're in VR and then you see these 3D models of some neurons and there's a storytelling aspect to it. Okay, and this one is something that I made recently with the Professor Pixoto's group.
Created in collaboration with Santon Lab from the University of California, San Diego. We will guide you through several
So it's a VR
stations
application
to learn more about
that
the importance of coral reefs,
talks about
and the
the
research that we are
importance of
currently
coral
developing.
reefs, the dangers of
Coral
climate
reefs
change
are
to
extremely
corals,
important ecosystems.
and
Despite
the research
relatively
that
small
the group
area
is
they
doing
cover, about a
to
10%
to
of ocean
address the
floor,
challenges.
Coral
Yeah?
reefs provide many ecosystem services.
So what you see in the background is an
Coral
actual
reefs are
3D model
diversity
of
hotspots.
the reef where
They
they work
support
in,
more than
which is pretty cool. And then there's basically like some videos and some 360 videos talking about the research. So this is great for teaching. So they put this in a conference. So it's great for outreach, yeah, and storytelling in general. Yeah, exactly. So it's exactly the same template. So the museum I'm going to show as well later. But yeah, it's kind of the same ingredients, right? But you just change the data, change the story, and it's a new thing. Yeah, so that's that for let's say the overview of AR, VR, and how they're typically used for data visualization. And now that we know that, hopefully by now you have some idea about, okay, how can I use my data set for this? How can I use AR, VR for my data? Is it helpful for me? If so, I want to show you now what the Visualization Core Lab can offer you, right? Like, what can we do for you? So you don't have to start from scratch. So now you have KVL to help you answer this question. And first of all, we can help you with hardware. You don't have to buy it, right? I mean, it's an investment. These headsets are an investment, especially the bigger ones. I mean, it's just basically not practical to get another one of these. But the headsets, I mean, you can buy them. But before buying them, you can ask us to try it out first, right? To build some simple prototypes. So hardware and then software. So we have license for some really powerful software. As I said, TechVis, with just a few clicks. If you're working in a VISO, you're in VR. We have some educational license for Unity that you can use for developing your application, and we can help you and teach you how to use it as well. And we can help you pre-process your data, right? So that it can be compatible with like 3D or AR, VR visualization software. Not only that, so part of my job, as I mentioned earlier, is helping people with segmentation. So if you have image stacks and it's challenging to extract the 3D structures from it, I can help you, right? And these days, there's a lot of hype on using AI tools for segmentation, and I can help you with that as well. So this is an overview of that, right? So we can give you access to hardware, help you with software, and help you turn your data into compatible virtual content. So basically all the ingredients we can help you with. So just getting more into the details of these. So for hardware, we have a bunch of headsets. So we try to buy like the newest ones just so we can keep up with technology. The Apple Vision Pro, maybe, we'll see, depends if there's budget. So one person has tried it before. Anyone else tried the Apple Vision Pro? No? Curious about it? No? Yeah? So we'll see. I mean, it depends if there's demand. We might get it. I mean, just for the sake of, okay, checking out, is it good enough right now? Is there interest in it? But later you can try the HoloLens, okay? So, yeah. So an audience here said like the Quest 3 has similar features, kind of, right? The Quest Pro too, right? Like they now, I mean, it's becoming more and more popular, this see-through feature where you put on the VR headset, but it has a camera that shows you the real world as well, but blurry. So it's kind of similar. So before you buy an Apple Vision Pro, if you have access to these headsets, try it out first. We also have AR devices, although the latest one we have is the HoloLens 2. Also important are AR, VR ready workstation. So depending on your application or the size of your data sets, you might need something powerful. And we have workstations that you can use. and laptops as well, and the bigger immersive environments. So we have Zone 5, which is on the other side. We're going to check it out later. We have Cubes, which is just on the other room. And yeah, you can book all of these through our website. Yeah, there's a calendar there. You can check the availability and just book it. And reach out to us if you need help using them. So in terms of software, yeah, so the first thing that I want to talk about is Aviso plus TechVis. So yeah, I mean, not many people here are using Aviso, but for those who are, so Aviso is super powerful with the image processing, 3D, like image segmentation, just 3D analysis. There's some simulation stuff going on there as well. And it's great for generating images for papers, for example, right? You can do measurements. There's a lot, right? And it's free for people in KAUST. So I recommend that you try it out if you're dealing with image data or 3D data. Now, the cool thing about this is this one, by default, it works on your laptop, computer, workstation. But we have a license for TechVis, which is a plugin that allows you to basically bring your data to VR with just a few clicks. And not just the headsets, but also the big display, right? So this is great for, I don't know, if you have a presentation or you have visitors and you want to show them the cool stuff that you're working on. And here is a video showing how easy.
Here I have my RockCT project opened, and I added an orthoslice and used the orthoslice to clip my surface view. We create the TechVis connection object in Aviso, and then start the TechVis controller. Make sure that the headset and controllers are detected. Click the VR icon and then the Aviso window. And in the TechVis module, click Connect and then Autoscale. Now you can lift the VR headset to your head height, and then click the center button to move the model in front of you. And then you can now put on your VR headset and grab your controllers. You can now click the grab button or use the grab button to bring the model close to you and move it around. And use the trigger button to directly interact with the modules in VR. And as you can see, in just a matter of a few minutes, we are able to switch our visualization and interaction from the desktop into virtual reality. And now we can open any of the open modules in VR so that we can change some of the parameters directly in VR without switching back to our desktop. For example, here we can change the slice orientation. So just keep in mind that you can use any of Aviso's visualization modules directly in virtual reality. Next, we will take a look at how we can use the Unity game engine for VR visualization.
All right. So this next video shows you kind of this same process. I mean, it doesn't show the details, but using similar process, you can then bring your data into the cave display, right? And super easy. It's a nice benefit if you're already using Aviso, okay? So yeah, that's one. And then, so the other main thing, so I would say this is the most common approach that I personally use, is using Unity game engine. So who among you has used Unity before? Awesome, awesome, great. So Unity is, as I said earlier, it's a game engine. So it's a software for building games. So this is how it looks like. So yeah, I mean, I won't go through the details, but basically you build your 3D world in here. So you import 3D models of a scene of your game, basically. And then you can import 3D models as well. And that's how we usually bring in the data sets, right? So, for example, for the ANPERT exhibit that I'll show later, from the CT scans, we use a Viso to do segmentation. From the segmentation, we extract the 3D model, and then you get assets that look like this, right? So this is a rock core sample, this is a coral, this is an insect. So you get the 3D model, and now you can import them into Unity. Super easy, drag and drop. Once they're there, you see it right away, right? It's just there. And then, I mean, with a few simple things, you just do, you can add interaction, right? Like grabbing the thing, maybe slicing it, different kinds of interaction, right? Depending on what you want to do. And the Unity basically allows you to build applications that will run on your PC, right? That will run on headsets, that will run on phones. I'm not sure yet on the web, but it's a multi-platform or cross-platform tool, right? So you just build it once, then you can deploy it to different devices, which is pretty cool. So I will just show a video here. So this is the exhibit that I showed earlier, and yes. Okay. So yeah, just to show you some of the elements that are, let's say, easy to have in a VR application. So you have like text display, so you can tell a story or put instructions. You can put 3D models, allow the user to grab them, move them around, inspect them, throw them, you name it. And there's some simple physics there, so there can be collisions and stuff. You can scale your models, right? Like this coral, as I said, I just scaled it up, made it gigantic, and then boom, it's a dome where you're inside your data, right? And for some applications or some data sets, this could be cool, right? Like just a fun or different perspective of your data. For instance, I mean, just while this is playing, we had one student long time ago who developed a VR application to build the connectivity map of neurons. But instead of tracing, she made it a game where you're basically driving through the tunnels, through the neurons, and you're driving through and clicking. And your goal is to go in the middle of the neuron, right? Because you're inside. And then as you play the game, you build the skeleton of the neuron, which is pretty cool. Makes it more fun, I guess. And then, yeah, this is a scan of a fish. And you can see the shells that it ate on the belly. So these are, I mean, just pretty cool stuff that you can do in VR. There, so you can see through this inside the spine, for instance. We actually wanted to make a roller coaster game where you basically ride through the spine of the fish, but we didn't have time. But that could be cool, right? Anyway, I'll skip this, so you can try this later on. But this is using Unity, and this was developed in like around 1 week. No programming, or like very little programming, because we used, I mean, this one is basically a Unity template. So they provide a template that you can start with, so you don't start from scratch. So we just modified it and put our own things inside, right? This is another example that I did 2 years ago. If you're familiar with the Shusha Reefscape Restoration Project, this was something I did for them. Again, it's using Unity. So basically, they give me a 3D model of the coral reef, so from photogrammetry, and then I download some open source 3D models of corals, and I build this application where you can virtually go into the reef and just plant corals, right? So it's good for outreach, for training, and so on. But this one requires a little bit more programming because of the complex interactions. So this is just another video with someone else using it. So you can have simple navigation as well. So you can teleport or swim around, whatever is more comfortable for you. And you can see here like the garden that this person planted already. Okay.
Lab from the Red Sea Research Center.
So yeah, again, this is
This
the
project is based on a 3D model of an actual reef created.
this was the Coral Probiotics Village VR application that we did. It's talking about the research, and we also used Unity for this. So this one of the challenges was just the size of the model, right? So the reef model itself, the original source is a point cloud with 4 billion points. And from that, we have to generate a mesh. And depending on the power of your computer, I mean, you'll have to like generate lower resolution mesh from that. We ended up with 10 million triangles in the mesh. But of course, if you have a powerful computer, you can have more. But yeah, we also used Unity for this. Yes, so again, I just showed those examples to you to give you an idea. The other benefit of using Unity is that we have another license, Get3D, that now allows us to bring your Unity application into these big displays as well. So, for instance, the Coral Probiotics Village, we're able to bring it here as well with a little bit of effort, just like 30 minutes to an hour of tweaking, okay? So that's a really big plus. And this is just showing that in action. So this is the reef, and instead of using the VR controller and the headset, you can use this display and the controller. So again, this is great if you have a group and you want to experience this as a group, and if you're giving presentations, this is awesome. So all of this hardware, software, resources we have available for you. So you can request it via this email address. Tell us about your data, what you want to do, and then we can meet and then discuss your project. And finally, aside from hardware and software, of course, if you can do it yourself, great. But if you need some expert support or you want to collaborate on some project, you can approach us as well. So we do some research on AR, VR for data visualization. So this is also, how I say, like an emerging field. So there's research on like, okay, does AR, VR actually benefit users in performing data visualization tasks, right? So if you have a unique domain where you think AR, VR can help, let's talk about it. Let's discuss if we have an idea that we can try, right? Let's use AR, VR to explore X data to get X insight. We can write a paper about it. If it's, yeah, we'll have to see. But this is possible, right? That's what I'm saying. We do other things, so mostly consultation. So for instance, we can help, as I said, convert your data into something that you can visualize in 3D. We've done commercial software testing, right? Someone here in KAUST is interested in a VR software, but they don't have the equipment yet. So we let them try it. Consultation, so some labs in Kingdom actually want to build their own AR, VR labs, but they don't know where to start. So they come to us and then we discuss the different hardware, software requirements, and so on, right? Again, this email, reach out if you need help, particularly for those who are in the live stream in Kingdom. So I think we've advertised the workshop today to some universities in Kingdom where they don't have yet an AR, VR facility, but they're just starting. So you can reach out to us and we're available for consultation and collaboration. So we're gonna continue now. So yeah, so far I gave like a quick intro to AR/VR technology, some examples of common applications, and then I talked about how AR and VR can be used for research, and what are the advantages of AR/VR that we can leverage for data visualization and interaction. And also, I talked about the resources we have at KVL that you guys in KAUST can take advantage of, like hardware, software, and expertise. And now, we're going to go into live demos and discussions, right? So what I want to happen here is for you to try the hardware out, try the applications, ask questions, and hopefully, I mean, if you have ideas, we can discuss them. Start them now, but later we can continue discussion after the workshop, and hopefully start new projects. So for the sake of the live stream, because they won't have a chance to try it out here in person, what I'm going to do is I'm going to go through 3 applications and show them myself, but I will share the screen so you can see what's going on and the people in the live stream can see, and also already give you the instructions how to use it, okay? So that I don't have to give you the instructions one by one later. So I'm going to start with the VR example, this one. And then we go to AR, and then VR again, okay? So let me use it myself first. So actually, because it's already loaded, I'll just use this one. I'll just use this one. I think it's more flexible. So this was this is a virtual reality exhibit that I did for ANPERC, right? And as I said, these are the data sets here come from the CT scans that they did with their collaborators. Let's put some sound. Yes. So yeah, you can see what I see, right? And I've already given a preview of this earlier. So for those who are here who will try it later, so there's actually a guide here for the controls. Okay, you can see it. So for today, we'll just use the right joystick. And I mean, the joystick is pretty comfortable to use. And if you just relax your hand, the fingers will fall naturally on the button. And the index finger here, what you see here, falls on the trigger button. And it's usually used for clicking, right? So if there's this button, I point my pointer to it and click. That's what you'll use. And then there's the grip button on the middle finger. And to me, this feels natural. I mean, it changes per person, but if you press that button, it feels like gripping the controller, you know, it's like grabbing something, you know, but try not to use this. So that's for grabbing things, right? So you can put your hand on top of an object and then grab it. So let's actually try that. So let me point my cursor to this button and click. Remember, click with this. And I'm into the next spot. There's an object. So if I put my hand on top, usually it changes color to tell you, hey, you can grab this. And now I press the grab button and boom, it's in my hand. And I can move it around as if I were holding it. So it feels super natural. I can drop it, just release the button. I can grab it from a distance. So if there's something far away, I can point my arrow and grab and let go. That's the main thing, right? And I developed this application so that even, let's say, people who are not familiar with VR can navigate by just using these buttons. So if you click, you're in the next station without walking. So you can walk. Oops. So you can walk if you set up the area right. You can also teleport. So there's a joystick here. You can point to a place you want to go to. And let go, and you're there. But people can get lost, right? Especially those who are new to VR, can just go get lost and lost in the experience. And then there's 3D interactions. Just be careful not to smash the laptop. But for example, you have 3D buttons like this. So the fish, you can grab and inspect it. There's things like this, like, you know, I can water this pot and a plant comes out. So this example just shows you like the different kinds of interactions you can have. So this is the insect, right? So I can see the scan of the insect here. If I push this button, oops, no. The other thing comes out where it's split in the middle. So I'm not sure if it's obvious, but you can see the hollow inside of the insect. And there's posters here that talk about the data, right? And then here, there's a game. I mean, I'm not gonna play it, but there's a game where you can like grab the thing, right? Take it out. So this is more of an educational kind of engaging people, telling them about your data kind of application. Not really for research. And then you have things like this. So you have the coral core, again from CT scan, and you see here a video of the core as seen from outside. But on the bottom, we used a VISO to extract the voids. So these are essentially the holes inside the rocks. So you see them here. Yeah, so it's basically seeing inside the data, right? Yeah, so that's it. That's the exhibit. And again, it's more about simple interactions, telling a story about the data, okay? So you'll get to try this later. Yeah. The what? Yeah. Yeah, so the question is, how does the application know when I press the button? So basically, it's connected by Bluetooth to the headset, right? And the headset is collecting all the information. And in this particular setup, my headset is connected by cable to my laptop, and the application is running on the laptop. So all the information gets sent to the laptop, and I process that information, right? Oh, yeah, yeah. So if basically, right, I press a button physically on the controller, there's a signal, right, that comes out of it, goes to the headset, and the signal is received. It's up to you, the developer, to do what you want with that. And one of the things you can do is push the button in the virtual controller so that you see there's like, it feels more realistic. It's like one-to-one. I'm not sure if it's obvious actually, but in VR, if you move the joystick, the virtual joystick also moves, right? And if you push the button here, the virtual button moves. It just adds like an additional sense of realism. Yeah. Yeah, you can do that too. No, it's in Unity. So in Unity, so this application that I have open right now, this is Unity, right? So this is the game engine. And like you see here, these are the different elements inside my scene. There's different objects. And for example, let me just click one. So, yeah. So for example, I click this object, that's the coral, and then on the right there, you're gonna see the different scripts. So these scripts add, let's say, gravity, physics, collision detection, interactivity, and you can code these, or there's templates available that you can just use. So for instance, me, I did not code much here. I just used the templates from Unity, okay? Yeah. Yeah. Hmm. Yeah. So this one was also Unity. This one is very old, but this is Unity, and they used I forgot the name, but it's something they bought. It's a hardware from Google, where they just connect their sensors to this device, and then this device connects to the PC via USB. And there's like a software from Google that allows you to process the data. And there's a plugin in Unity, or I mean, you can implement something where Unity can receive the signal and process it from there. So it's all about bringing your data into Unity and writing code to process that. So now I'm going to show an example. So actually, wait, I think I've already shown it to you, the one with the coral. I'm just thinking, I mean, let me show that, or let me show something cool first. I mean, just for fun. So the HoloLens comes with a built-in 3D viewer. This is super fun. I mean, with kids and for first-time users, this is pretty cool because they have like a library of 3D models that you can just bring into the world. So fun models like this chameleon biking. But I mean, these virtual humans are amazing. I mean, the astronaut. You see it, right? Okay. So I have the astronaut right now. And I'm going to put this guy here. Look funny. But now I'm going to make him life-size. And now I have an astronaut with me in this room. Can you see? Okay, yeah. And I'm going to make him move. Ooh. I mean, hi, bro. I mean, this is awesome. Life-size astronaut there. I mean, pretty cool. You can try this later. I mean, for research, yeah, maybe. I mean, Daria here I was chatting with her earlier. So she was talking about using the HoloLens for training, right? So this could be something where you use it, right? Like you have a life-size virtual world, a life-size experience. Like you have a patient there and you have to do CPR or whatever. It could be a great application, or it could be a great tool for that, right? So to implement virtually something like a dangerous situation or something where non-experts have to deal with expensive or dangerous equipment, then you can do it virtually first, do a virtual training before they do the actual thing, right? Pretty cool. Actually, anyway, I'll keep him there. But this is the example that I want you to play with later. This is the sample that I showed before. And here you have the different objects, and you can play around with these, right? So there are different things here. So we have this virtual whiteboard, which is hard to write on. But what I wanted to say is for the HoloLens, your controllers are your hands. So you have to do this gesture, okay, for clicking and for grabbing, right? So there's an arrow. Once you do this gesture, and kind of a line shows up in front of you. You point it on the object you want, and then click, and then it's there, okay? And you can do, for some objects, you can do two hands and stretch them like that. But for some object, just do one. And then there's different interactions you can play with, okay? So you can play around with this later. No. So, I mean, that's the thing, right? Like the HoloLens can only interact with virtual things, right? But like for you, I cannot grab your phone or like do something with you. Yeah, but this is the thing. It's bringing the virtual into the real world, right? So now I can put this thing on the table, on the desk, And for example, I don't know, like if you have some machine, where there's data coming out of it and you want to see the data in real time on top of that machine, you can do it like that, right? But that's it. I cannot. So there's some companies that do something like this, right? So they have virtual panels. So let's say they have equipment, like complex equipment, and they want to control it through AR. That's possible, but you have to implement that, right? So you can have a control like this, like I don't know, start engine, or increase temperature, things like that. So you have a virtual control of a complex system. That's possible, but you have to implement that. Yeah. Yeah. So this is also implemented using Unity. So Unity is super powerful. I mean, of course, other engines can do that as well. But Microsoft, the mixed reality team, they work directly with Unity people, and they develop SDKs, or software development kits, that make it easy for you to implement, right? So you just download it. They have a template. So this is a template. And basically, I just put in my own data, which is this coral and the protein, and grab their scripts and put it on these objects. So it's super easy. Like the basic stuff is super easy. And yeah, if you want to go more complex, then of course you need to implement more complex stuff. But you can also use Unity here. And there's a SDK, it's called MRTK, Mixed Reality Toolkit, for this. Yeah. So that's a good question. So the question is about if you want multiple users to be in the same environment or to see similar virtual stuff, that's actually possible. And there's different ways to do it. But the most common is you have some server that runs the application, or actually all the HoloLenses are running it, and the server sends the information to all the HoloLenses, because all you need is the position, right? Position and the interactions. Then you can just apply them to the same application, and it synchronizes everything. It's the same with VR. So there's multiplayer games. Usually you have a server that synchronizes everyone, but it's possible. It's possible. All right, so I'll go to the last demo, and then we're gonna end the live stream. Okay, so this was the art exhibit. So I guess we're gonna go to the Coral Probiotics Village. It just takes a while to load. And as you can see here, it's basically just a regular Windows application, right? So I just double click it, make sure my headset is connected.
You are about to experience a virtual reality project developed by KAUST Visualization Core Lab and the Marine Microbiomes Lab from the Red Sea Research Center. This project is based on a 3D model of an actual reef created in collaboration with Santon Lab from the University of California, San Diego. We will guide you through several stations to learn more about the importance of coral reefs and the research that we are currently developing. Coral reefs are extremely important.
So I'll pause that first. I mean, this is pretty cool, right? So this is, as I said, this is a scan of an actual reef. So if you go diving in this reef, you're gonna see similar structures. Of course, the resolution is not, super fine, but you kind of have a rough idea of where the corals are, the shapes of the corals. There's fake fish to make it like nicer. And the background is an actual 360 photo that was taken underwater. So this is the actual, it's low res, but this gives you a feeling of being underwater, the same location. So this particular example, as I said, it's more of a storytelling application. So you have text here, you have video playing, and you have a panel here. So same as the other application, you need this clicker button, okay? And you can go to the next station, right? So I'll just click that.
Most of the world's coral reefs are currently threatened by local and global pressures. The main
So it brings you through the journey, but just like the other one, if you enable free exploration, you can teleport and explore the area freely. But based on my experience, a lot of people, especially the ones who are new to VR, they get lost and like fall off or whatever, and it breaks the experience, right? So we usually hide that capability. We even disable buttons because people like, press buttons accidentally and like just ruin the experience. So this is one thing. Anyway, I want to show you the next one.
The scientific community is looking for solutions to preserve coral reefs while the reduction of CO2 emissions and the improvement of environmental conditions are achieved.
This is a
These
360
solutions
video.
include several interventions to increase the adaptive capacity of corals and restore coral populations. These solutions include several interventions to increase the adaptive capacity of corals and restore coral populations. But the only medicine being currently explored to retain native corals is the use of.
So this is a type of content that is kind of easy to acquire, right? You just need a 360 camera and you go to the site you're interested in, underwater, in the mountains, in a cave, wherever, and take a 360 video and record that, and boom, you can bring it in VR and have people explore that experience like this, right? I mean, of course, you don't have much freedom. Like, I can't really walk around, but I can look around wherever, and if there's events happening all around, then it's still a way to immerse users into your scene, right? Into your scenario. By the way, like YouTube has 360 videos, so you can explore those as well. But this is just, it adds a additional element of presence, right? And there's just these additional buttons here that you can click that tells a different story every time. And yeah. Oh, and you can see the fish. I mean, these to me is the highlight. I love fish, so unfortunately you cannot catch them, but this is pretty cool. And these are also programmed, right? I mean, I just bought some asset. So the message here is you don't have to build everything from scratch. There's actually what's called an asset store in Unity, and you can buy assets, right? So these 3D models of fish that are animated, I just bought them for $5, and boom, I can put them here and I have fish, right? And there's lots of other assets that you can just buy and add to your project, so you don't have to build everything from scratch. Yeah, so the question is if it's possible to have the video plus these animations. Yes, because what happens is the video, it just gets, the way it's implemented, you can imagine a sphere is surrounding you, and then the pixels of the video are just mapped to this sphere, and it's just there. And it's just playing, but you still are inside the 3D environment, so you can still see your controller. If you want to put some objects, 3D objects in front of you, that would still work. So yeah, there's a lot of possibilities. I mean, it's just a matter of knowing a little bit about what technologies are there, looking in the asset store, Googling stuff, right? Like, how do I do this, do that? And you can do it, right? And there was a guy asking earlier during the break, how do I do this? How do I build the Unity applications? Where do I learn it? So Unity has nice learning resources. So once you run Unity, so for example here, this is Unity Hub. This is the application where it manages your projects, right? So I have my 4 different projects here. It manages the Unity versions, so I have different versions of Unity. And then on the left side, you have Learn. And this is where you can find learning resources. And they have a lot. And they're really good. So see, you can, I mean, there's a lot. You can do basic game development for mobile. Yeah, the essentials, I would say you can start with that. the Unity editor, and so on. There's 2D games. There's for VR. There's certifications as well. So there's a lot. And online, if you just search, if you have a problem or you have a question, 99% of the time you will find the answer. And this is what I do, right? I mean, yeah. So, any questions before we go to the live demos? Okay, cool. Yeah, so these three applications that I showed, I mean, we're going to spend a few minutes with the people who are around here to let them try it out. And later on, we're going to move on to the showcase. So that's this area in Building 1, Level 2, the other side, where we have the bigger setups, and we're going to try some other things there. So for those in the live stream, I'm going to end it here, but maybe I show you the other things we will try in the showcase. So if there's time, we're going to try this out, the coral planting using the VR headset. This one as well. So the Aviso plus TechVis license, it only works in 3 places here in KAUST. So that's the room on the other side and 2 in the showcase area. So we're going to try that out. We're going to try this as well if there's time, or maybe we'll do this first, so all of us can experience this cave example. And then this one, the one I showed earlier, where we explored the bathymetry in the big screen. And that will be the end.